What's up, everyone, and welcome to the January 2024 live stream for the Geometry Regents. So, yeah, anybody in New York who's taking this Regents, this will probably be most helpful for you. And I mean, anyone else is welcome to be here if you have a geometry final coming up, or if you're in a future math class, uh, Algebra 2 or something above, and you just want to learn or brush up on some geometry, everybody's welcome to hang out. So, yeah, we're going to go through some questions. I will wait to see in a few minutes, like how many people we could get in the chat or how many people we could get in the live stream, just so before I just start talking about math questions, I have a few people here to get started because I did say 8 o'clock. Now, I am going to do my best to go through the whole regions, in this one stretch here. But if I can't make it through the whole regions tonight, then I will, do my best to finish it tomorrow night. And then I also have Algebra 1 that I will be doing later this week, and I have Algebra 2. So I plan on doing a Regents review for the three math regions. That's my plan. And yeah, anyone who stops by from an AP class, I do plan on in May doing AP Calculus live stream reviews, and I'm also going to do Regents reviews again for the June Regents as well. So yeah, that is my plan. All right, I want to follow and make sure that this thing is actually up and running here before, I really get rolling. So let me just see. It says that we are here. It says excellent connection, but I just want to make sure that I actually. Okay, so I am seeing the live stream popping up. So it says we have a few people on right now. All right. Anyone is, of course, here. Welcome to say something in the chat. I just want to make sure that everything's good before I get rolling here. I'm going to wait maybe another minute or two to get started. But yeah, once again, I am going through as much of this test as I can. All right. Well, I guess anyone who really wants to see a specific question, could always rewind. And also, if you have questions of your own, please, you're welcome to type them in the chat. All I'll ask is just please be respectful in the chat. I know in prior years we've had tons of people in the chat just absolutely like took off. But yeah, if we could just keep it real in the chat, that's my only request. All right, but also ask away whatever questions you have. All right, so question 1 here, we have which object is formed when the right triangle RST shown below is rotated around leg RS. Okay, so what I'm thinking about here right away is we're rotating the triangle around this line segment. So if we take this triangle and we rotate it in this direction here, we just need a little bit of an imagination for these questions, but just imagine which shape would be formed if the cross sections are right triangles. This would form a cone. Okay, so I'd have something, looking kind of like this. Not my best artwork. I'll try again. All right, I'll try one more time. All right, that's a little bit better. So you can see here when it's spinning this way, we would have a cone. So for question 1, choice 4 is going to be, our solution. Now, looking at the other answer choices, the reason why we don't have a pyramid is that a pyramid is not circular. Okay, so this doesn't have this is not a circular shape. I wouldn't describe a pyramid as circular. You see here, if I were to draw a square base pyramid like this, you could see that the sides here are, so this is not my best artwork, but you get the idea, that the sides here are not rounded. Okay, this is not generated by rotating. This you would actually generate by if you were to stack up a bunch of squares. See, like my cross sections, if I cut it this way, are squares. So if I just stack up a bunch of shrinking squares, that's how you build a square pyramid. Okay, so that's more Cavalier's principle. So that's why 1 is no good. And then 2 and 3 are out because these are like 2-dimensional shapes. Okay, when we take a 2D cross section and rotate it, it's going to make a 3D solid. So that's why, yeah, those ones I crossed out in red are no good. All right, so this one, the vertices of triangle JKL have this. All right, so really for these kind of questions, let me see. We have under which transformation is the image not congruent to the original triangle? So with these, I automatically think, like if I have a triangle and I translate it. So translating just means I take this triangle and I move it. no matter where I move it, that triangle is not changing shape, okay, or size. So I know choice 1 is out. Translation is not going to do it. If you rotate something, okay, so let's say I take this triangle and I spin it. So I take this triangle here and I just start spinning this thing around. So am I going to be able to select this? Let's just see. So I have this shape here, and let's say I group all of that and I start rotating it. You can see it's still congruent, this triangle. I mean, like whatever triangle I get is congruent to the original one. It's not going to change shape just because you rotate something. So choice 2 is also no good. And then reflecting it over an axis is also, you know, if I were to reflect it over, let's say the x-axis, I'm just saying is here, the triangle that I get is going to be equal and opposite on the other side. So this one's no good. But a dilation, I always look for the dilation. A dilation would be if I, let's say, draw in my dotted lines like this. So I have a center and I draw in my dotted lines and I dilate this triangle by a scale factor of 2, then notice here from this distance to this distance, I would double that distance. And then from here to here, I would go equal out away from here. And then from here to here, this space, I would go, let's say, about to this location. And notice this triangle here that I'm drawing is essentially doubling the length of all the sides. So this new triangle in blue is definitely not congruent to the original. But honestly, with these questions, when they say which one's not congruent, I'm always just looking for the dilation with a scale factor other than 1. Oh, so at Rose, thank you so much. Oh, I'm happy to help, Rose. And I'm glad you were able to use my videos for Algebra 1. I'm really happy making these videos. Being on YouTube now over 10 years, I would say the prize, honestly, is like really just knowing how many people this is reaching. So I appreciate, even back in my, beginning stages, my first year on YouTube, I had, let's say 100 subscribers in that first year. But it was like, for me, it was so much fun, like just, being able to interact with everybody, so I appreciate you being on the live stream, Rose, and commenting. So, thank you so much. All right. Oh, and also people could let me know in the chat, like if the video and the audio is clear. If anything's out of whack, just let me know. It's saying the stream's bit rate is lower than the recommended. All right. I mean, whatever. I'll just keep rolling here though. If there's no complaints, then, I'll just keep going through these questions. So next we have center of circle Q has coordinates. So this is our center. And then they tell us that the circle Q passes through this point. So this is on the circle. What is the length of its diameter? So for this question here, I mean, you could plot these, but honestly, all I'm thinking of is like, all right, I have a circle. So I'll use the fact that, let me try that one more time. I think this program makes, oh, it's not making a circle. All right, so it's just making me look foolish. All right, so here's a circle. And they're telling us that the center, I'm not drawing this necessarily to scale, is 3, -2. And then they tell us, so 3, -2, I'm just imagining is in quadrant 4. And then 7, 1, somewhere over in quadrant 1. But I guess like, where it is doesn't truly matter. But the radius of this circle is going to be the distance between these 2 points. So then it helps to know the distance formula. The distance formula is we have x2 minus x1, then squared, plus we have y2 minus y1 squared. And from here, all we have to do is to find this distance. And the distance we're going to say, let me just fix that. So that's squared. The distance is the radius. Okay, so I could call this r equals or distance equals. And now I just apply the distance formula. So I could call either one of these x1, y1, x2, y2. But let's just say I call this x1, y1, and this one x2, y2. So here I would have 7 minus 3 squared plus, and then I have 1 minus -2 squared. And this is going to work out to, we'll have 4 squared plus 3 squared, and that's the square root of 25, which is equal to 5. Now this, like, just be careful, all right? Please don't choose that, LOL if you do. I mean, no, it's not funny, I guess, if you lose points. The radius is 5. The diameter is 2 times the radius, okay? So just make sure when you take tests like this that you read very, 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 very carefully, because it's so easy to do like all this amazing math and then you just misread what the question was actually asking for, and it just throws everything off. Now, for this, they said graph paper. Yeah, I mean, you get graph paper at the end of the test, like on the last page or something is graph paper. So just know that this is also an option. Like you could just go 1, 2, 3, and then down one like this. And then let's say 7, 1 is 4, 5, 6, 7, and then up one like this. Okay. So, oh, I'm sorry, that was -2. Let me just fix that. So let me just go. So we have 3, -2 is over here, and then 7. So we're at 3, 4, 5, 6, 7, and then 1 like this. So let's say you forget the distance formula. One thing you could also do is go rise over run. So from -2 to 1, I would have to go up 3 boxes. And then to go from 3 to 7, I have to go over 4. And notice it makes a right triangle if I draw in this line here connecting the two. So the distance between these 2 points would be the hypotenuse of this right triangle, and this is a 3, 4, 5. Okay, if I had to check, I could just do 3 squared plus 4 squared is equal to the distance squared. Let's say I call it c squared, or r squared I'll call it, just so that it once again matches the fact that it's the radius of the circle. And you're still going to get r equals 5. Okay, so that's just an alternate way of doing this, just in case you forget the distance formula. But either way, we're getting choice 3. Okay, so now for this question, what we have is we have a diagram. Let me just zoom out a little bit. And we want to know which sequence of transformations maps figure 1 onto to figure 2 first, and then figure 2 onto figure 3. Well, what I'm noticing here, if I just look at this, so let me see if I could just draw this in one motion. So 1, 2, 3, 4, 5, 6. All right, that's not my best artwork. But notice the first time around, we're just sliding. Okay, so we're translating first. And I pay attention to, like, let's say one, like 1 or 2 points, like AB is going to map to A prime, B prime. And notice I just slide. So translation is first, which means choices 1 and 2 are out. But now let's think about what's going to happen here. Are we going to reflect to get from here to here, or are we going to rotate? The problem with reflecting is that a point like A, see how like A is over here, or I'm sorry, A prime is over here, that would send me straight down to the x-axis if I reflect this way. And then it would send me down again like this. So A double prime would have to be over here if we reflect over the x. I know we're not reflecting over the y because that would put us in quadrant 2. So this one's out. It has to be a rotation, but you could even see here, if you were to rotate this, so I'll show you all a little trick that I like to use, is, I mean, I could just screenshot this the way that I have it now. So I'm just going to take a quick screenshot, and then I'm going to rotate this picture here. So we have this, and let's say I rotate this 90 degrees clockwise. Do you see that what we drew in red here is mapping exactly to where this one is? And notice that we have A prime, B prime, C prime, D prime, E prime, F prime. A prime would map to A double prime. So notice that it's in the correct order too. We have here, it's like A, B, C, D, E, F, and we have A, B, C, D, E, F. All right, so I just honestly take my test paper and I turn it just to see that it matches. So for question 4, we're going to get choice 4. All right, so this one, we're going to need to do some, looks like we're going to have to do some trigonometry here. All right, oh, look at that, and we have a tree, trigonometry. I'm sorry, I can't help myself. That's just perfect how that worked out. That was not planned. All right, so what we have here, the angle of elevation is 34 degrees if the point is 20 feet from the base of the tree. So they're telling us here the angle of elevation from a point on the ground. So the point on the ground, the angle of elevation is 34 degrees. And then they said if the point is 20 feet from the base of the tree. So they didn't label this for us, but the point, the distance from the point on the ground to the base of the tree, the base means bottom. Okay, so this here, the base of the tree, let me just make that neater, means the same thing as bottom. Okay, so the base of the tree. What is the height of the tree? So we want to know, let's say I call this, I'll put an X here. So I know it's trigonometry because we have an angle on the inside other than the 90-degree angle here, and we know one of the sides. So if we know one of the acute angles and one of the sides, we have to use trig. So then this mnemonic helps, SOHCAHTOA. This will tell you which function you have to use. So we know this angle here, 34 degrees. And if we look across from 34, x is the side opposite. And then the adjacent side, well, next to the 34 degree angle is the side that's 20 feet long, and this side is adjacent. Okay, the hypotenuse is always across from the right angle. But the fact is, I'm looking for opposite, and I know adjacent. So when you say opposite, adjacent, you should be thinking of the tangent function. Okay, so just know, like in general, like what I'm thinking of when I hear this mnemonic here, what this mnemonic means, like for T, for TOA, is that tangent of the angle, theta, is equal to the ratio of the side opposite of theta over the side adjacent to angle theta. So here, that's why I'm using the tangent function, because I know I'm looking for the opposite and I know the adjacent. So I have tangent of 34 degrees is equal to, we have x over 20. And now just cross multiply and you've got x equals 20 times tangent of 34 degrees. Now, one thing you have to be very, 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 very careful of is for situations like this, you have to make sure that when you use a calculator, all right, and let me just check that everything's looking good here. So let me just I'll move this over. Is that when you use the calculator, you have to be in degree mode. See, right now I'm in radians. So I'm going to go over to mode and I'm going to switch to degrees. When you take algebra 2 and you have to graph trig functions, then you want to be in radians. But for the geometry regions, just make sure that you're in degrees the whole time. So you have 20 tangent of 34. You press enter, and to the nearest tenth is going to be 13.5. Now, let's say for a moment, let's see what happens if we are in radians. So I go up here. All right, so hopefully when you see that the height of the tree is negative 12.5, a tree can't have negative height. That would mean like the tree is growing into the earth or something, if you want to think of it in a weird way. So then hopefully your alarm bells would go off and you would know to switch it over to degrees. Okay, so it should be 13.5. So here we're going to say x is equal to 13.5. So choice 3 is our answer. All right, moving on. Which figure can have the same cross sections? Which figure could have the same cross section as a sphere? All right, now for this one, I like to imagine that like, not like I'm I'm a samurai, all right? And I have a sword and I'm chopping these things. And I want to think of what shape would I be looking at if I chop it. So first thing about cross section, same cross section as a sphere. The word cross section though is a big idea. Just know that that means like I think of it as just a thin slice. Okay, like you could think of it as you're like at the deli and they slice meat or cheese. Like one slice is a cross section. So here, just imagine like I chop this, okay? And I see like what shape am I looking at if I chop this? Well, the cross section, a very thin slice here, if I go like super, super, super thin, would be a rectangle. But I need to have the same cross section as a sphere. So just imagine this is like drawn well. Okay, here's my sphere. The cross sections of a sphere would be circles if I chop it this way. So I'm really looking for which 3D shape has a cross section that's in the shape of a circle. So notice that all of these are, the sides are planes, like they're flat. So one I just know is out. This one here is out because, yeah, if I take cross sections this way, it's kind of looking like a trapezoid type prism. Here, a trapezoidal prism, if that's the word for it. Okay, so I know 3 is out. This one's not circular. This one is also not circular. The cross sections here look like they're going to be, yeah, not circles. So the cone is it. All right, we could see here, if I cut it this way, thin slices, the circles, the cross sections here are circles. The circles are shrinking as we move to the top of the cone, but if we slice it horizontally, we have circular cross sections. So 2 is going to be our answer here. All right, so for that question, yeah, you need to be able to imagine kind of like what's actually happening here. All right. So yeah, that is the question 6. All right, now question 7. And remember, if you have any questions and you want me to explain something again, or you just have like, random geometry questions, like concepts you want me to explain a little bit more, let me know. All right, so question 7 here. Let's see. A shipping container is in the shape of a right rectangular prism. So sure, draw out a rectangular prism. Okay, drawing it helps. You don't always have to draw, but I find that it helps. The length is 12 feet. So we'll go ahead and label this. The width is 8.5 feet. So I'll say it's not drawn to scale. And this is 4 feet. The container is completely filled. Can cross sections cut vertically? All right, so let me just rewind back. Yes. So if I had taken, let's say, this cone, so the answer is still 2. And I cut vertically like this, you could see that I have a right triangle as my cross section. But which figure can have the same cross section as a sphere? All right, so this one, yeah, this one here, we just have to be very careful. It's which one can have the same cross section as a sphere. Not, so anyway, we cut these. See how like I cut this one vertically, I cut this one horizontally. So in this case here, you know, our cross sections are, see, still rectangles. All right, so this one, even though it's possible for me to have something, you know, that's not a circle, but if I do cut it horizontally, I get a circle. So which one can have, not which one, the only cross section is a circle. They're saying which one can have a cross section that's basically a circle. All right, so good question though, because that's yeah, something we have to be mindful of. I'm just gonna put my phone on silent here. Sorry. Here we go. All right, we're back. So what we have here, the container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. Okay, so I'm just going to write that over here, 0.25 pounds per cubic foot. And what we have is, we want to know what is the weight in pounds of the contents in the container. First, we could find the volume, because this is basically telling us, you know, like the density. Okay, because remember, density is equal to the mass over the volume. All right. So here, like I know technically mass we measure in kilograms, at least in physics. But for the geometry regions, we're just going to say like mass over volume. We're referring to the weight in pounds over the volume, in this case in cubic feet. The formula sheet. Oh, let's see. Oh, we have some people. Let me see. Will there be a formula sheet in our test packets? Yeah, basically it's the same one on every single regions. All right, like if I zoom all the way to the end real fast, and then I'll come back. Actually, I don't know why I'm doing it that way. I'll just go like this. So if you look at the last page, this is the formula sheet you get. So there's not even a density formula. There's the volume of a prism, cylinder, sphere, cone, pyramid. So there's some okay ones for geometry, but not, yeah, they really don't give you a whole lot. All right, so let's go back to this question. And here we are. So the volume here, I'm just going to find, we're going to do the volume is, we have the length times width times height. So I'm going to multiply these three. Okay, and they don't tell you to write the units, but feet times feet times feet is cubic feet, or feet to the third power. And then what I would do here, so let me just shrink this down. Actually, that just put it in full screen. Let me go here, is I'm going to do 12. I'll clear this. We have 12 times 8.5 times 4. And in a moment, I'm going to multiply by 0.25. But I'm just going to explain kind of why I'm multiplying in a moment. All right, so first, I'll just get this over here, just so we have it on the ready. Okay. So let me just move this out of the way so we could actually see it. All right. Actually, that didn't help at all. Let me crop this. All right, that's much better. All right. Actually, yeah, I'll just move it over here so that we have these numbers on the ready. So what we just found is that the volume is 408 cubic feet. But to find the mass, or the weight, we would just multiply. So we would multiply the volume of the rectangular prism by the density of the contents, and that's 0.25, and the units are pounds per cubic feet. So that's why I like to write units, even though in the free response you're not graded on units, because it shows the units canceling. And then 408 times 0.25 is 102. And notice that the only unit we're left with is pounds. Okay, so choice 3 is going to be our answer. All right. So let's just see. Oh, the comments. Hello, we've got more people. Very nice. I want an 83, 80 or above. I'm glad. Just rely on your calculator and you'll get it. Yeah, so at Fortnite, Sweaty Kid, nice to see you again. I know you've been on plenty of my live streams. Some of the names I do recognize. But it is, the calculator, if you know how to use it well, can really get you far. And when I do the Algebra 2 Regents live stream, I'm going to show you there are questions that say, hey, do the algebra. But if you use a method other than algebra, you get half credit. So if you're on a 4-point question and you're like, I have no idea how to do the algebra, you can use the calculator in like a clever way and, at least get 2 out of 4, which is better than getting nothing. So yeah, I will stay tuned for that live stream. Oh man, I don't want no more Regents. Yeah, I know the Regents are somewhat exhausting, but I kind of like having a prize at the end of the year. I don't know if you would really call it a prize, but it's good to just really seal all the work you've been doing all year. And it's the one test. I mean, I would argue it's the same maybe for AP exams as well, that you could kind of go into knowing what they're going to ask you. Like they're not going to tell you exactly what's on there, but if you do enough like full Regents to prepare, then yeah, you'll be fine. So just do the best you can. All right. And yeah, I'll try to show as many calculator tricks as I can. So let's see here. What do we have in the diagram of circle A? So now moving on to question 8. I did this ahead of time just so that my explanations are a little bit smoother, because I don't want to think out loud, while I have everybody here. So let's see, we have chords intersecting, and which statement is not always true? So be careful with these nots, because you're probably going to find something true right away, and you might be like, oh, there's my answer, and move on, and just read carefully. So which statement is not always true? So anytime I see intersecting chords, I'm always thinking similar triangles, because that's how you prove a bunch of the theorems involving intersecting chords. So one thing I notice is let's say arc CF. See how this angle over here, E, is intersecting arc CF, and so is angle D. So when you have inscribed angles that intercept the same arc, those inscribed angles are equal in measure. Okay, because remember the relationship, whatever this angle is over here, let's say I put like a 2x here, the inscribed angle is half. Okay, it just cuts in half. So if this was 2x, then both of these would be x, and they would be equal in measure. So that would mean that they're congruent. And then we have intersecting line segments. So these are vertical angles. So you see how these two triangles are similar. So which one is not always true? This is always true. These two triangles are always going to be similar when you have intersecting chords and then you form two triangles. Okay, they're always going to be similar. And now if we look at the rest of the statements, basically say angle CEG, see this angle over here is congruent to angle FDG. That is always true. Anytime, once again, when you have inscribed angles intercepting the same arc are congruent, right? If you want to jot this down, inscribed angles, okay, that intercept. So I'll just say, yeah, intercept. I'm just abbreviating for the sake of time. The same arc are congruent. Okay, so that's just good to have. And then look, once these triangles are similar, think about the ratio we could set up. So CE over, and this is writing a little sloppy, so CE over EG. See CE and then EG. If you have trouble looking at the corresponding side in the other one, pay attention to the letter arrangement. So CE is first and second letter, and then FD is first and second letter in this triangle. And then we have DG underneath. DG is second and third. And then if we look here, we have, let me just see, CEG. Did I write something? CE. I'm just sorry. I'm thinking about out loud. Oh, I should have wrote EG here. I'm sorry about that. This was CE over EG. Forgive me. All right. So let's start that sentence over. So CE over EG. See how it's like first and second letter over the second and third letter. And then in this triangle, I have first and second letter is FD over DG over here. So that's how I know these are corresponding, just using the letter arrangement. Okay, remember the letters have to be in corresponding order. Okay, like angle C has to be congruent to angle F. Like these two angles are the same over here. And then like E, this angle, and angle D over here are the same. So just know like the letter arrangement really does help. So that's how I know this one here is always true. So it has to be this one. But let's think about why that one is not always true. So if we look, CG is this line segment here. And then FG is this one over here. So what that would tell us is that these two triangles are always congruent. And then that would mean their corresponding sides are also congruent. But here, notice that these two triangles are not congruent. Like this one here is visibly shorter than this one, the way we drew it. You can draw it in such a way that these line segments are the same, but we want to know which statement is not always true. Okay, that would mean every single time we have intersecting chords, those two corresponding sides of the similar triangles would be the same, but they're not. Okay, so that's why it's 1. In geometry, what's nice too, it's very visual, so you could just kind of eyeball this and be like, that doesn't look like, that kind of looks like it's not always true. So your instincts would get you there. But knowing all this background theory about, these two triangles being similar is the safest way to get there. So, oh wow, thank you for the comments. And then at Kevin K, thank you so much. The calculus goat, I appreciate that. I really do. But I'm doing my best just to keep providing everybody with good videos. I'm doing my best to keep them strong and keep improving. But thank you so much for the recognition here. Thank you all. I'm happy to help you all so much. Oh, pre-calc. So yeah, good. Pre-calc is I actually taught that class for a really long time. I plan on adding more pre-calc videos down the line, the single topic. Lately, I've been focusing on, I have to finish up. I have one more AP Calculus unit practice test video to make. And yeah, and then I'm going to start planning, putting some materials together for the AP Calculus review. But over the summer, I'll see what kind of stuff, what my schedule looks like. But I do want to add more single topic stuff. So can I teach IB mathematics since I teach AB? IB mathematics, I'm going to be honest and say, wait, what is IB mathematics? Is it, I'm guessing it's challenging at Fortnite Sweaty Kid, because I know you don't play around with math. If it sounds, let's see, is it difficult? Is one of the most challenging classes in the IB diploma program curriculum. Oh, cool. I could look into it. I mean, that sounds fun. So yeah, AP pre-calculus. I don't teach that this year at my high school. They, I got offered to teach it, but I already teach 4 periods of AP calculus. So I was like, you know what? I asked this year to teach a geometry class because I miss teaching Regents classes also. I was really just teaching, pre-calc and AP calculus for a really long time. So I'm happy to be back in geometry. But I do have a book on AP pre-calculus. So, I had planned on, getting some work in with making sure people would actually see. Yeah, I was planning on learning the curriculum and stuff because that's the thing. People say, oh, you teach AP calculus, so I bet you could do every AP pre-calc question in your sleep. And it's well, no, I'd have to learn the curriculum because there's always some unique twist they put on the class. I mean, I'm sure I would be fine with a lot of the material, but there's nuances to some of those questions that I'd have to get familiar with. So yeah, Regents classes can be so scary. But look, the worst thing that happens, Rose, is that, if you don't do amazing, it's you're still you. And you just, you learn as much as you can from now to the test. And if you don't master it by the test, I always tell my students, the test is just showing where you are that day. It's not the finish line. It doesn't, it doesn't show where you're going to be weeks or months from now. So also the secret is, I would say, to study as if to study as if, the test, like almost like you had a test every day. Because I mostly see people on these videos and live streams like in the highest volume, like right before the test. Of course, because people want to like get as much information as they can. But it's way better to learn this like a little bit each day. Okay, so for this question here, slope, y-intercept. So for this one here, the slope of the line we could find by solving for y. So I could go, let's say, plus y on both sides. Okay, and if this is where your algebra skills come in. If you are like really, really, really strong with algebra, like let's say you aced algebra 1, then this part you could probably do in your head. All right, but if algebra 1 was like a little bit funky, you're like, algebra 1 wasn't my best friend, and this part could get a little annoying, that little bit of math. So the slope of our line is 2. Now the concept you need to know, which equation represents a line that is perpendicular to the line represented by 2x minus y equals 7. So you need to know that perpendicular lines, the slopes, are opposite reciprocals. Okay, so opposite, I'll abbreviate, and then reciprocals. Okay, that's actually how you spell it. All right, so here, opposite reciprocal, what that means is I take 2, and I'm going to call it 2 over 1, and I'm going to make it opposite, so I'm going to make it negative, and reciprocal means to flip. So I'm going to flip that to 1 over 2, so I have negative 1/2. So my perpendicular line is going to have a slope of negative 1/2. So I look at all of these remaining answer choices, and only one of them is the coefficient of x equal to negative 1/2, and it's choice 1. Now, one thing I have to point out here is that all of these lines are in y equals mx plus b form. They're in slope-intercept form. Okay, this line is more in standard form here. But an alternate way this answer could have showed up is they could have had something like this. Like, let's say you have y equals. So this is also a possibility, just to point out. If they wanted to be a little annoying here, they could have written this in standard form. So let's say I multiply everything by 2. I have 2y equals negative 1x, because I'm just doing, 2 times negative 1/2 is equal to negative 1. Okay, so I have negative 1x, or just negative x, and then plus 6. And then I could add this to the other side, and I could have something like 2y plus x. Make that neater. Yeah, something's going on with this program that I write with. Sometimes the writing gets a little choppy. So, all right, so 2y, like this is a way they could write all the answer choices. Because you see how they gave us the line in standard form? Sometimes they'll write the answer in standard form as well. Okay. A Discord server. Thank you for mentioning. So at wintertime, do I share the PowerPoints? Let me, I think I put a link to this test in the description. Okay, otherwise just, I could put it in the chat, I guess. Let me just see. I could do, why not? I'll use JMap. But it should be in the description. June 2015 is the regions I'm doing. But I have to get Discord set up. I know there are, I have to level up my live stream game. Being a YouTuber, there's like a lot of stuff that you have to learn and work on. And I could definitely do a better job of that. So thank you, Wintertime, for putting that phrase out there, because that's, got my wheels spinning for the next live stream to make it better. All right. So let's see, which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? So this one, all I think of is 360 divided by the number of sides, okay, because it's a regular polygon. So like if I think of a easier one, something like a square has 4 sides. And if I rotate it about its center, and you can just visualize this here. If I rotate this thing about its center, 360 divided by 4 is 90. So if I rotate a square about its center by 90 degrees, that's going to spin it onto itself, okay? When we say spin it onto itself, we mean that when it lands, it looks exactly the same as what we started with. Okay, so this formula tells you what your minimum rotation is to carry a regular polygon onto itself. Right? Like that's the concept. So I like to draw it out with the square first, because drawing out a decagon is like not going to be pleasant. So yeah. All right, let's see. Oh, and thank you. I see more tips coming in. That's so kind of people. Yeah, I really do appreciate the support. So yeah, thank you all. I really means a lot. Like just knowing that 54 people have watched this already is like just very cool. But I like to be able to do this for people to see people, get some help before the big week coming up. So yeah, once again, thanks for the support. All right, so 360 divided by however many sides there are is going to equal 45. Like you see how in this case, they're giving us the minimum rotation here. So for this one, if you could do the math in your head, great. Otherwise, just cross multiply. 45n equals 360. Divide both sides by 45. And you could calculator this. N is equal to 8. Okay, so n is equal to 8. So which shape has 8 sides? And it's going to be an octagon. Okay, so then you have to know a decagon has 10 sides, hexagon has 6, and then a pentagon has 5. Okay, so octagon is 8, and this one is 10. So choice 1 is our answer. Cool. All right, so this one here is let me see. All right, so I didn't learn this material yet. I'm supposed to take it in June. Oh, cool. Yeah, no, I would encourage people who are taking geometry right now. You may not recognize some of this stuff, but it's definitely cool to check out. So you'll definitely learn some stuff. Oh, next black pen, red pen. I appreciate that. I think I'm going in a different direction than black pen, red pen, but I do appreciate the mention. He's definitely like one of my favorite math people on YouTube right now. He's very inspiring. Like that guy. He's over 1 million subscribers, I know, at this point. I'm subscribed to him. I mean, I do love watching his channel. So thank you for putting me in the same sentence as black pen, red pen. All right, so let's see. EB is parallel to DC. So this one, if you know the side splitter theorem, this question, you could use the side splitter theorem. Okay, I should make this all capital too, in case there's any English teachers around. Okay, so side splitter theorem, that is a proper noun. So make sure you capitalize it. No, don't worry, they won't take off points if you can't grammar. All right, so here, 9/5. So you see, the reason this is working, the reason why we could apply the side splitter theorem is that this triangle is being cut with a line that's parallel to one of the sides. So these sides are going to be cut proportionally. So I could say 9/5 is equal to 9.2 over x. And now just cross multiply. 9x equals 9.2 times 5. And for this one, so we just work all this out here. So I can multiply those two. So why not? We'll use a calculator, or I could just divide everything by 9 all in one shot. So let's see. Yeah, I don't know why this is really, maybe because I'm live streaming right now, so it's a little bit laggy, this program. Eventually I have to upgrade my computer. Okay, so x equals, and then I'm just doing the product of these two numbers divided by 9. And this is going to give us 5.1. Now, this is what I was talking about before. Please don't do something like this. All right, this is a very dangerous bear trap. Okay, there's always those answer choices waiting for you. Please, before you move on, ask yourself, are you actually answering the question? They're asking you for the length of AC to the nearest tenth. So AC is the entire segment here, is 9.2 plus x. So I need to do 9.2 plus x is 5.1. Okay, so please, once again, just make sure that you're reading as carefully as possible. And this is going to work out to 14.3. All right? Can you do proportions backwards? 5? Yes, you absolutely can. Now, there's an alternate way to do these questions, which maybe I'll just show right now, because there is danger with the side splitter theorem. The worst thing that you could possibly do with the side splitter theorem is like basically use the side splitter theorem when you shouldn't be using it. So the parallel lines cut the two sides of the triangle proportionally. That doesn't mean that like EB and DC are going to be proportional to like, let's say 9/5. So what you could also do is you could draw the triangle separate. Like you could go little triangle is AEB. So you could do little triangle and just write your 9 and 9.2. And then you could draw the big triangle. So the big triangle here is ADC. Okay, so 9 plus 5, see, like 9 and 5 I would add to get 14. And then this side would be 9.2 plus x. And then if you do it this way, then you could just do, in this case here, like 9 over 9.2. So like left to the right equals 14 over 9.2 plus x. All right, and then here, you just do the algebra. You'd have 9 times 9.2 plus x equals 14 times 9.2. And then from here, it's like the same idea. Just do the algebra, and I promise you're going to get x equals 5.1. But some people might prefer this method more because this will work even if they give you, like, let's say EB and DC. Because if they give you EB and DC and you use the side splitter theorem, it's a bear trap. Okay, but drawing the triangle separate will get you to the right answer. All right, so that's just another option. But for the sake of time, I'm just going to keep cruising on here. All right, so question 12, which equation is always true? We have a right triangle. So this one, I just automatically know they're shouting out this concept. If you know anything about cofunctions, then you know that sine of, let's say, angle A is equal to cosine of the other acute angle over here, angle B. And the reason behind that, so let me just pull up the calculator, is if I have sine, so let me clear this out. Sine of, let's say, 50 is that ratio. Okay, that decimal there. If I do cosine of the complement of 50, so the complement of 50 would be 40, because 50 plus 40 equals 90. Remember, complementary angles add up to 90 degrees. So if I do cosine of the complement, you see how it matches. All right, and this, I promise you this works every time. If I have 70, the complement of 70 is 20. And they match. All right, and it doesn't matter if I did sine 20 first, and then I put 70 with cosine. It's always going to give you a match. So here, like, let's say this angle here was like the 20. See, this is 90 because it's the right angle. This one would have to be 70 over here. Okay, so that's how I know sine A equals cosine B. All right, that works. If that, like, it was kind of tricky, you could always just make up a triangle here. Like, you could call this a 3, 4, 5. And you could find the ratios yourself. You could say, like, all right, sine of A equals opposite of A is 4 over the hypotenuse is 5. And then you could say cosine of B, cosine is the ratio of the adjacent to the hypotenuse, is also 4 over 5. So, like, that's how I know choice 4 is it. All right, so those questions are, like, not so bad if you know which, like, what's going on. All right, so question 13, we have a quadrilateral. We have the diagonals. Which information is not sufficient to prove that ABCD is a parallelogram? So this one, it really just helps to know the properties of a parallelogram. So if your diagonals bisect each other, that means you have a parallelogram. Because let's say I just draw this like as somewhat random as possible. Like, here's our parallelogram. Okay, and then from here, I draw in the diagonals. Now, you get a, at the Regents, you could, like, use your student ID to make straight lines, but just draw this as neatly as possible. And you could see, like, yeah, that looks reasonable here, that the diagonals are cutting each other in half. So, like, 1 is good. Okay, if we have ABCD, so you have ABCD, and we have AB is congruent to CD. Yes, the opposite sides of a parallelogram. So we have AB is congruent to CD, and then we have BC is congruent to AD. Opposite sides of a parallelogram are congruent. Okay, so now I'm just going to get rid of this inside stuff because now we're not focusing on the diagonals. So yeah, opposite sides of a parallelogram are congruent, so that's always true. We want which one is not sufficient to prove that ABCD is a parallelogram. And then we have AB is congruent to CD, and then AB is parallel to CD. So yes, if one pair, so if they just talk about one pair of opposite sides, but they tell us that they're congruent and parallel, then that is enough for us to say that the quadrilateral is a parallelogram. So just by process of elimination, it has to be 4. But let's understand why it's 4. So for this one, so I want this to go away. Let me see here, ABCD. Oh, okay, so this one, they're saying that one pair of opposite sides are congruent and the other pair of opposite sides are parallel. So that could be an isosceles trapezoid, right? If I was a better artist, it would look nicer. But let's say these two sides are the same, and then these two line segments here are parallel. So here, if I have, let's say A, let me just see how am I going to draw this. Yeah, I'll put D here. And then we have A, B, C, D like this. That'll work. See, AB is congruent to CD, and then BC is parallel to AD. So in this case here, see how it satisfies 4, but this is clearly not a parallelogram. Okay, so what we would need is the sides that are congruent and parallel would have to be opposite of each other. Okay. Question about proving. Let's say we are given a quadrilateral is a parallelogram with diagonals bisecting each other, and I proved that vertical angles are congruent and that segments bisected are congruent. Oh, okay. If you have that it's a parallelogram, so let me just draw that out. I have to like kind of understand like what's going on here. So parallelogram. Well, once you know it's a parallelogram, like you could say all of these answer choices. Let me just see. So we are given the diagonals bisect, blah, 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 blah. And the segments bisected are also congruent. Okay, well, if the segments are congruent as well, diagonals are congruent, mean that's a rectangle. But can you also say those triangles are congruent here? All right, so this, yeah, you could use side angle side, but then what you could also say is that the opposite sides of a parallelogram are congruent. So you could use the side postulate. There's like a million different ways, yeah, this could apply. So if I'm understanding your question correctly, Fortnite, yeah, SSS would be fine. Well, you don't know the outside segments, but if you look at what Fortnite said, he says, we are given a quadrilateral is a parallelogram. Once you know you have a parallelogram, you could say the opposite sides are congruent, and your reason is opposite sides of a parallelogram are congruent. All right, so yeah. Oh, completing the square, everybody's favorite. I know completing the square is like awful for people because when I look at my videos, like the engagement and like where people watch the most, it's like on algebra, it's always like completing the square that they really tune in. So, all right, so the concept of completing the square is completing the square, I think of perfect square trinomials. Now, the algebra you need to know is you have to think of, take the b term, you cut it in half and square it. Okay, and I'm thinking about when you have something in the form of like x squared plus bx. Okay, and then everything else doesn't matter, but the coefficient of x is what matters. And you want to have a 1 in front of the x squared. So notice that we have 1x squared and 1y squared. So we're like ready to complete the square. So now I have x squared plus, and I have y squared plus 6y. And you know what? I'm going to leave a little space. I'm going to write x squared and actually, no, I'm sorry. I don't need to leave a space. I was going to do something. I was thinking of writing it one way, but I'm just going to do it this way. All right, so I'm leaving a space here. So this one, the y squared plus 6y, that's the piece we need to complete the square. So when I look at the b term there is a 6. So I'm like, all right, half of 6 is 3, then squared is 9. So that is the mystery value I'm going to add to each side. I'm going to go plus 9 on both sides. And what this accomplishes, what happens when we do half of b squared added to both sides, is it completes the square. It turns this into a perfect square trinomial. So now x squared, you don't have to write it like this, but you could if you want. You could call that x minus 0 squared. You'll see why in a moment. Plus this, I need two numbers that have a sum of 6, and the two numbers also have to multiply to 9. And the two numbers would be 3 and 3. So I'd have y plus 3 times y plus 3 is equal to 7 plus 9 is 16. So now I have x minus 0 squared plus y plus 3 squared is equal to, and you know what, I'll even rewrite this as 4 squared, because the formula that we need is x minus h squared plus y minus k squared is equal to r squared. Okay, this is the equation of a circle where the center is the point HK, and the radius is r. So if I look here, one thing to pay attention to is that in the formula, notice that we have x minus h gives us an x coordinate of just h. So there's an opposite relationship. So x minus 0 squared, I could just say my x is 0, and then opposite of plus 3 is minus 3. So that's my center. Okay, my center is at 0, negative 3. So like these are out. And the radius here is equal to 4. All right, a radius of 16 is like very depressing. All right, that's like they got you at the final stage. Just remember that it's equal to, the equation is equal to r squared at the end. So you have to think of what's the square root of 16 is 4. That's why sometimes writing it as a square could be helpful. Okay, so that one's equal to 2. Oh, let me just see here. Did you find out part 2 of that? Oh, someone asking about a different question. All right, let me see. Is that one coming up or something? All right, so 15. Moving on here. And similar triangles. Oh, just know similar triangles is like 30% of the regions, 30 to 40%. It's a massive part of the region. So if there's anything to be good at for geometry, for the regions, be really good at similar triangles. All right, so we have AB is equal to 9. BC is equal to 15. And we have DE is equal to 6. EF is equal to 10. We have angle B is congruent to angle E. And which statement is true? So this one is side angle side similarity. So notice that these two triangles have these angles in common, and then these two sides between them. I'm checking if 9 over 15 is equal to 6 over 10. Like, are these going to be in proportion here? So if I reduce this one, I divide the top and bottom by 3, and I get 3 over 5. This one, I'm going to divide the top and bottom by 2, and I also get 3 over 5. So this tells me here that these two triangles are similar. So which statement is true? Triangle ABC is similar to triangle DEF. Like that one is, oh, wait a minute, ABC, DEF. And then they say, oh, the angle. Okay, so this, I just want to make sure this didn't say triangle also, because I'm like, wait a minute. That would be like kind of weird if they did. But let's see why this is no good. So angle, I'm going to guess right away because they're not in corresponding order. So notice angle CAB, the middle letter is A. And angle DEF, the middle letter is E. So notice that this angle over here at E is not in corresponding location as this angle over here at A. See how B is matching up with E? So that's why this one is not a statement here that we could say is true. AB over CB. Okay, so this is like the short side over the long side is equal to, we have the long side over the short. Okay, so that's the problem with choice 2, is that they're doing 9 over 15 is equal to, and then FE is 10 over 6. So you can see like this is less than 1. And this one is greater than 1. So that's how I know right away this is no good. So that's why that's out. And then we have AB over DE equals FE over CB. So I mean, this one just set it up. It's also not true. So 3 is it. Let me just see. So question, what do I do if I was told what is the reflection or rotation about a point? Oh, okay. So if you reflect point B about 2, 1, okay. All right, let me just go to a piece of graph paper. So graph paper. Okay, here. So at Fortnite, so in your question, that's a good question. If point B is at 6, 3, so 1, 2, 3, 4, 5, 6, and then up 1, 2, 3. So what if you had a point B at 6, 3, and you reflect it about 0.21? So let's just say that's our point of reflection. For this one, a point reflection is you go straight to the point and then you go the same distance through. So I just use the rise over run method. I have to go down 2 and then over 1, 2, 3, 4. So I'm thinking like, all right, I'm going down 2, and then I'm going over 4. So I go down 1, 2, and I go over 1, 2, 3, 4. So that would send like, let's say B prime is at -2, -1. Okay, so I like to call it the rise over run method. Okay, that's how I do it. And you can even see if I connect these like this, you can see how like the distance from here to here matches the distance from here to here. All right, so it's just going straight to the point and then straight through. But the rise over run method is the secret. Yep, that's it. Yeah, no, simple works. So at Fortnite, yeah, I can't memorize complicated rules. With geometry, it's more about understanding the concepts. All right, so I like really make sure I get the transformations and what they actually mean, because then it can be so simple. It doesn't have to be like some insane formula that has like 58 components. That's just going to make everybody sad. All right, so triangle ABC is here, and it's dilated by a scale factor of 3. So let's just say like now it's like way bigger. All right, so here's the new triangle. So drawing helps. So 3 times, and I could pick out random numbers, like, I don't know, let's say 4, 6, and 8. All right, not drawn to scale. So if I scale factor by 3, like scale factor of 3 means multiply everything by 3. So 12, hopefully I'm multiplying right. 6 times 3 is 18, and this is 24. So now ask yourself, is 3 times 12 equal to 4? Nope, not true. All right, so that one's out. B prime, C prime is 18. Is that equal to 3 times 6? Yes, but I'm going to check the other ones just to make sure I didn't like overthink something. All right, so this one's a misconception. When you dilate a triangle, so a dilation, the angles are the same, okay? So the angles do not change. Okay, the size of the shape changes, okay? The size changes, except in the boring case, like if they made a scale factor of 1, that would just be like absolutely the worst. There'd be no point to it. But in that case, like sure, it would stay the same. Everything would stay the same. But any other scale factor, like it's going to change the size. Yeah, spatial knowledge for sure. 100% it's testing. So yeah, also at Fortnite. All right. So 3 times the measure of angles. Yeah, so this also. The angles are the same. So if another correct answer, which statement is true, would be the measure of angle, let's say C prime, is equal to the measure of angle C. Like the angles don't change. So 2 is it. All right, moving on here. So Steve drew in some line segments here and formed a scalene triangle. Which statement will allow Steve to prove that these 2 line segments are parallel? So for this one, you want to have like either corresponding angles are congruent connecting this line up here to this line here, or alternate interior angles. So I'm looking at angle CFG is over here, and FCB is over here. And notice we have that Z shape. So right away, this is looking good. But remember, if choice 1 is looking good, please check the other ones. All right. Let's see. So angle ABF. So why is choice 2 no good? ABF is congruent to BFC. Well, if these were congruent, then that would mean that this and this are parallel. But yeah, because you see how like that would be alternate interior with this. If they said ABF is congruent to BFG, then that would work. Okay, ABF is congruent to, actually, am I lying here? Wait, ABF and then BFG. Yeah, that would work. ABF and then BFG would work. Okay, but that's not the case here. So that one is out. If we had, let's see, why are the other ones no good? So EFB is this angle. If that was congruent to CFB, yeah, no, that's not good because that doesn't even connect what's going on up here to what's going on down here. So that one's out. And then we have CBF. So I'll do that in purple. So this angle over here is congruent to GFC. Yeah, these also are not like alternate interior or anything here. So that's not going to work. this is a scalene triangle, so I can't even have like these two here matching up or something. So yeah, 4 is out. 1 is definitely our best bet. Oh, at Renato, I'm happy to help. Yeah, I'm just glad I could. Oh, at Zane, I'm glad that my old BC stream helped for your semester test. I'm happy to hear that. So I'm doing my best to just. Oh, my channel was suggested on your feed the other day. Thank you for subscribing at Vanessa Kitty. I appreciate that. I'm happy to see the channel growing to what it has over the last few years. It's definitely been very exciting, like to know that these videos are going as far as they go. So thank you all so much for being a part of this, for sure. So all right, so we have this already. Dilation. I'm just seeing that's what's going on here. Scale factor of k. The center is e, and which ratio is equal to the scale factor of the dilation? Now, one thing to pay attention to here is that CD is the image of AB. So this is the image, and this is the pre-image. So I would label these, because if you mix them up, a common mistake, and they were trying to be funny here, is that everyone thinks like you start here close to the center and you go out this way. But if your scale factor is like, between 0 and 1, like let's say it looks like here, like k could be equal to a half. In that case, the line segment that you're starting with is going to go closer to the center. So let's just be mindful of that. And I'm getting that this is a scale factor of 1/2, because if I look, let's say from here to here, so from like D to E, I'm going up 1, 2, 3, 4 over 2. See, I'm going like up 4 over 2. So at Fortnite, this is the same. Oh, or maybe scale factor 3. So let me see. Up 1, 2, 3, 4 over 2. And then up 1, 2, 3, 4 over 2. Up 1. Oh, so this one actually, you know what? It's not a scale factor of a half. All right, so what can we do? So it's the point is, though, they're not asking us to find the scale factor. They're just trying to have us come up with a ratio that's equal to the scale factor. So the way this works, let me see. They're using EC, EA. They're using BA and EA. Yeah, those are, I'm just trying to see which one looks the most reasonable. EA, BA is no good. And then EA and EC. So yeah, this one I'm narrowing it down to 1 or 4. The reason being is that like choice 1 uses E to C over here and E to A. So you see how it's like kind of like it's along that same line like this. And then EA and EC is for choice 4. The problem with the other answer choices is, let's say choice 2, BA uses this piece. And EA is this piece. Like this is kind of just referring to the original line segment here, like the distance from this point to this point and then this point to the center. It's not really working with the new line segment they introduced. So like that's how like process of elimination, like I'm leaning it down, to these. But let's think about what's happening here. To get from AB to DC, if I had like, let's say line segment AB, I multiply it by K, and that's going to bring me to line segment DC. So to solve for K, I would just divide both sides by AB, and that would tell me K is equal to this. But notice like they didn't use that specific amount. So this is where we're going to have to get, a little bit creative here and think. So what I'm thinking of here, remember, K is between 0 and 1 because the line segment is getting smaller. Okay, so let's just think about that carefully. The line segment is getting smaller. So if I look here, EA is the long piece and EC is the short piece. So if I do like the long segment divided by the short segment, this is going to be greater than 1, but we said K has to be some number between 0 and 1. It has to be a fraction between 0 and 1. So that's how I know this one is out. And the reason why this one is good is this is the short piece. And this is the long piece, okay? And the short over the long, that is going to be between 0 and 1. All right, so that's how I know choice 1 is it. If you want to see a more direct way of getting there, is we could say that segment EA times K is going to be equal to the distance from E to C. And then we just divide, right? And the reason why we're multiplying EA by K and not EC is because EA, like A is on the pre-image. So we go from the pre-image to the image. That's why that one's going first. Okay, so either way, though, choice 1 is it. That's a hard question, though. So yeah. Oh, a semi-retired math teacher in the USA. Very nice. I'm happy to get as many people in here as possible from, all, different, I've gotten a lot of students, teachers I've collaborated with. I'm happy. I've had teachers chime in and say like, oh, thank you. And like, I use your stuff in my classroom. I've seen other people on YouTube that are, also teachers and checked out their content. So I just really like that this channel has helped me like kind of expand and build up a community here. So how do you remember, let me see, this much info? I understand it. So here, I would say at Fortnite, like the key is like going really deep. Before I became a high school math teacher, I spent time before I started teaching going through the whole curriculum because I was a math tutor first. I used to work at a place called Mathnasium. So I tutored kids from grades K through 12. And I told myself, I want to be able to prove like every theorem or formula that I would have to be able to use in like algebra, geometry, algebra 2, pre-calc, calculus. Like I really try to understand the proofs. And when you go that far, like when you understand a proof of a theorem, you never lose it. It's yours forever, as long as you continue to practice. So when you read any of these questions after you've gone that deep into the topics, they kind of like just deconstruct into these like little pieces, and you're like, all right, which way could I go? Like you're just so used to doing such deep analysis that these questions just kind of like, I want to say like they're easy. But if I'm like, this isn't really working for me, let me try this angle, let me try this angle. And like, I could usually find some way to the answer. So yeah, that's, I guess how I'm remembering so much. Proofs is the secret to retaining. It's all about understanding. And then it's not about, wouldn't say I really remember it. It's because I understand it. Like I could build the formulas. The ratio questions, and it's like, this might pop up at some point. Like the ratio, if I have like point A and point B, and point P is located in such a way that it breaks this up into a ratio of m to n, and then it'll be like, all right, well, just remember like this is x1, y1. So let me just, fix this. So you'll get things like, here we go. They'll say things like, this is the formula. So plus like m over m plus n. And then you have like, the distance x2 minus x1. Like, but if you just understand ratios and proportions, like this just starts to make sense. It's like, of course that would be the formula, because you just really spent time to get good at ratios and proportions. So it's not about like knowing a lot. It's about knowing a few things really, really, really well is the key to just being able to remember all this. So that's where. So completed, a master's in math in 20. Very nice. Yeah, no, I kind of wish when I became a teacher that they had, what's it called? I had to get a master's in education. I'm just looking to see if I have a bottle of water somewhere nearby. I do. So I got a master's in education, but I would have rather have gotten one in math. Not saying that, sorry, I've been doing a lot of talking. Not saying that I didn't get anything out of the education program. I just really enjoyed my math classes like a lot more. Because I believe education, like when you take education classes, the best way to learn how to teach is like kind of being thrown in a classroom. You could read a lot of theory on it, but like until you walk into an actual school and you have 34 kids in front of you, and it's like, all right, good luck, teach them math. And like everybody's different, and you got to like learn everybody's personality and try to balance the universe. It's a very interesting profession, teaching. Yeah, at some point I'll start talking about more like the teaching experience. Now that I've been teaching over 10 years, I guess I have a lot of stories, but I don't know. I just had to get more comfortable being on YouTube and getting stuff out there. But I think eventually, I'll start telling those stories. But it's cool hearing other people's stories. I also retired. Oh, the ASVAB questions came onto the feed and caught your eye. Very nice. Our teachers must get a. Yeah, no, like I would have loved to. I mean, I'm buying books and I'm constantly, trying to keep my skills sharp. I want to do a little bit more of a deeper dive, like in the next upcoming months. But for sure, like I would say it's valuable. I just think with the teaching shortage right now, it's gonna be hard to find a lot of people with that degree. I know some states are like waiving the master's requirement, like basically altogether. So, but yeah, for sure, math teachers should know their math. I agree. All right, so a gallon of paint will cover this many square feet. An artist wants to paint all the outside surfaces of a cube. Blah 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 blah. Okay, so the fact that what we have here is that 1 gallon of paint equals 450 square feet. So square feet means area, okay? So think surface area, because we're dealing with a cube. We care about the surface area. Okay, so surface area it is. A cube has 6 sides. So the surface area, like if you notice, each side is 12 feet. So 12 feet by 12 feet by 12 feet. Please don't do 12 times 12 times 12. All right, that would be the volume. The surface area, there are 6 sides, front, back, left, right, top, bottom. So I would do the surface area of a cube is 6 times the area of one of those faces is 12 times 12, or 12 to the second power. So now what we have is we have 144 times 6. And calculator, or I mean, we could just do this here. So 24 plus 2 is 26. And then this will be 8. So 864 square feet. And then what they're telling us, though, is that 1 gallon gives us 450 square feet. So we're really just dividing here. But if you want to see the units, 864 square feet, I'm multiplying by this conversion factor. So back to Algebra 1 mode. 1 gallon for every 450 square feet. So the units cancel out. We're doing 864 divided by 450. So let me just pull up the calculator. So 864 divided by 450. And we've got 1.92. All right, so 1.92. But now we have to think about this logically. So 1.92 gallons. You cannot go to a store and buy 0.92 of the paint and then just pour the other 0.08 you don't need on the floor and say, oh, it's all right, just charge me for this much. I don't want that other paint. Like, no, that's insane. So you have to buy 2 gallons. All right, so 19 is choice 2. So common sense. Oh, thank you, Janet, for the tip. And what's the comment here? Let me see. Whoops. Oh, I'm clicking on the wrong stuff. But thank you for the tip. What is that? Someone could type in. My eyesight is maybe if I go on OBS. Oh yeah, spoiler, I use OBS to do my live streams. Is that a salt shaker? It looks like a salt shaker. Thank you though. That's so sweet. All right. Now, moving on. More circles. Circle O, diameter AC means it goes through the center from one end of the circle to the other through the center. And they tell us AC is perpendicular to CD. So CD is a tangent to the circle. And we have a bunch of chords. Which statement is not always true? Okay, so for 20, let's go through this. ACB is this angle over here, is congruent to BCD. That looks reasonable, because notice ACB intercepts AB, and BCD intercepts this arc over here. So I guess what that would assume is that these arcs are congruent. That BC, this arc, is congruent to AB, but that doesn't have to be the case. You know, like I could draw this over here like this, and you see how this is like still a right angle, but like it's even more obvious this arc is smaller than this arc. So Not always true. One is already looking like it, but once again, if one is like looking like your answer, check the other ones just to feel safe. I recommend that you do that. Okay, so the next answer choice, why is it no good? That means it has to always be true. So ABC, and let me erase this. I'll clean this up. All right, so we have ABC, angle ABC is a 90-degree angle. Okay, how do I know it's 90 degrees? Well, they told us AC was a diameter, and this angle over here, ABC, is an inscribed angle. And since AC is a diameter, this arc all the way over here, so like I'll just highlight this, is 180 degrees. It's half the circle. So the inscribed angle is half, is equal in measure to angle ACD. Well, they told us that AC was perpendicular to CD. So this and this are like definitely always 90. All right. It doesn't matter where ABC, like where this point B is. If you're intercepting half of the circle, given that AC is a diameter, you're always going to have that 90-degree angle. So this one's always true. BAC is this angle over here. Let me just change colors. So BAC is congruent to DCB. Let's see why. All right, so this angle, inscribed angle, intercepts this arc. And you see how this angle built over here with the tangent and the chord is intercepting the same angle. So these, this inscribed angle here is half the measure of BC, and this angle over here is half the measure of arc BC. So that one's always true. And now for the last one, let's see, what do we have? Angle CBA, 90 degrees, is congruent to angle AEC. But notice angle AEC is inscribed and it's intercepting half of the circle. See, it's going from like A to C. So also 90. So those two 90-degree angles are always congruent. So one is definitely it. All right, so we're cruising through. We're getting to the end of the multiple choice. And let's see, what time do we got? 9 o'clock. All right, I'll try to go as far as I can. If I have to tap out, I'll just do the rest of the questions tomorrow. But for the algebra and algebra 2 live streams, I plan on just brute force going through them all. So AC is 12. And I'll stay with the angles. Complementary angle is, in a right triangle. Okay. I mean, I don't know if that's a stay with the angle. Oh yeah, so in a right triangle, the acute angles are complementary. Maybe that's what you're getting at Nathaniel Silver. But let's see, we have DE is 5, so just label. We have the perimeter. Oh, okay, so this one, just know they're telling us these two triangles here are similar. So when you know your two triangles are similar, that means that the distances are scaled from one to the other. So here, there's a few ways we could do this, but they're telling us the perimeter of triangle ABC, the perimeter of this triangle, is 30. So I could right away set up a proportion that's going to tell us the perimeter of triangle DEC. So here, what I notice right away is something like, let's see which side corresponds. So they told us ABC is similar to DEC. So you see how these are like a little bit flipped? Like if I'm paying attention to side AC, see how that's first and third? AC is equal to 12. And then if I look first and third here, DC is equal to 7. These sides here are corresponding. Okay, so these are corresponding sides. They are in the same relative location to these two similar triangles. Once again, the letter arrangement gives it away if it's like not jumping out at you in like an obvious way. Okay, so what that tells me is when I look at this, all right, there's a few ways I could go forward here, but perimeter is, for one, this is a one-dimensional measurement. Okay, perimeter is one dimension. Okay, area, I'll write this over here, is a two-dimensional measurement, and volume is 3D. So the fact that we're dealing with a one-dimensional measurement, we could just involve this in a proportion, the perimeter, and nothing bad's going to happen. One thing you have to be careful of, sometimes they give you similar triangles, and they have you answer a question about area. this is not a direct proportion. This one, you have to take the scale factor and square it. So just know, like, you have to take the k value and square it. For volume, you have to take the k value and raise it to the third. Okay, but here, not going to be a problem. So what I could do is I could say 12 over 30. So the ratio of AC to its perimeter 30 has to be equal to the ratio of the side that's corresponding 7 over the perimeter of this triangle, which I could call anything. I'll just call it x. So now I have 12x equals 210. And now divide both sides by 12. And we're going to have x equals, and here I'll just work this out. It's going to work out to 17.5. All right, I can say 12 goes into 21 once with the remainder of 9. And then 12 times 7 is 84. That's 6 away. And 6 over 12 is 1/2. So 17.5. Okay, would be the answer here. Another way you could do this is people would say something like, 5. So you could solve for the scale factor. So another way of doing this, you could say 5. So let me just get out of this. Okay, I could say 5. Actually, not 5. I'm going to use 7 because these sides correspond. So I'll say 7 times k equals 12. So k equals 12 divided by 7. And then what I could do is I could take the perimeter and I could scale it by 12 over 7 as well. Okay. Although in this case here, I'm sorry, let me rewind a bit. Yeah, you know what? If I do it that way, then I'm gonna have to do a little bit of annoying algebra. I'd rather go the other way because I know the most about this triangle. I know the side and the perimeter. So I would say maybe 12 times the scale factor k. So let me pretend I'm going from here to here. So this is just an alternate way of doing this. So 12 times k gives me 7. So k equals 7 over 12. So then I would take the perimeter 30 and multiply it by the scale factor of 7 over 12. And here, this is going to give me, once again, 17.5. Okay, so just another way of doing this. You don't have to do it that way, whichever one makes you happier. All right, 22, the line, blah, blah, blah. It's transformed by a dilation centered at the origin, which, okay, so dilated lines are parallel. This is what you need to know. And remember, the next concept is that parallel lines have equal slopes. So 2 concepts in 1. The reason being, if I have, like, let's say a line like this, and no matter which 2 points I scale. So let's say this is not the line in the question, but I do this. And this one I go like about here. You can see that when I connect these two, all right, not my best artwork, say like about here, that these 2 lines have the same slope. So what I'm going to do here is find the slope of this line. So I take this, I divide everything by 3. So that's going to give me y equals negative 2x over 3 is negative 2 over 3 times x plus 8 over 3. So notice my slope is negative 2/3. So now what I'm doing is I'm looking for a line that has the same slope of negative 2/3. And 22 is, I'm looking at this negative 2/3 without doing any algebra, looking like 1, but let me just double check. Yeah, it is going to be 1. So the algebra I'm doing in my head is I'm solving for y. Okay, then I'll show you another way to do this. That's like a little bit sneakier, but this is like next level algebra. Is you could put the original line in standard form. See how all the answers, these are all like everything here, this, and this are in standard form. So probably the cooler way to do this would just be to put this in standard form. Like just go, I'll write it this way, plus 2x on both sides. So you could just write this as like 2x plus 3y equals 8. And you see how the only one that has like a 2x and a plus 3y is the first one. Okay, so that's another cool way of doing this. And you see how it's like 2x plus 3y equals 8, and this one's equal to 5. That means their y-intercepts are going to be different, so they're going to be different lines. All right, otherwise, I take choice 1 and I solve for y. So I have 2x plus 3y equals 5. I do minus 2x on both sides. and then just divide everything by 3. So you see I divide everything by 3. And that gives me y equals negative 2/3 x plus 5/3. So the slope of this line is also negative 2/3. Parallel lines have the same slope. So choice 1. 23 was like pure evil. What's mean about it is like you could get away with doing the wrong math. Like if you really want to answer this the technical way, it would be a little bit of a harder question. The reason being is they're breaking this circle up into 24 congruent sectors. A sector, just know, is like a slice of pizza. If you eat pizza, I feel like most people have at least tried pizza. That's why I use that analogy. All right, sorry if you've never had pizza. If you haven't, like, I would try it. All right, so the thing is, this is not linear. All right, so I'm just emphasizing this because what I'm about to show you is like not technically okay if I really want to get down to the true math here. The linear piece would be this distance here. Okay, so I don't know. If I take 360 degrees and I divide it by 24, okay, this is going to work out to 15. Let me just double check. Yeah, that works out to 15. So that would mean like if I do this the true way, I have a 15-degree angle here. I would drop down this here, making a 90-degree angle. They're telling us the radius is 5. So each of these angles now are 7.5 degrees. And I would use trigonometry to find the length of this. Okay, then double it and then say, all right, if there's 24 congruent sectors times 12 will tell me the length x, the value of x. All right, so that is like really, really going deep here. What they had in mind, because I did it both ways, was they're saying, no, you could use this piece of the circumference because as you get more sectors, okay, like let's say as the number of sectors goes like to a big number, like goes towards infinity, like the arcs like become like almost like more linear. Okay, like they're like kind of flattening out a bit. All right, like you could see like if I only had 4 sections like this, and there's like a 90-degree piece, like this distance from here to here is clearly not close to this one. All right, but like as they get tinier and tinier, like that distance, like in this, are like really, really close to each other. So like 24, I know is not infinity. It's not like heading towards, like it's not that big of a number, but for the sake of what we're doing here, it's fine. All right, so my point being is that really all we have to do here is we take the circumference. The circumference is pi times the diameter. If the radius is 5, the diameter is 10. And we divide it by 24. Okay, so the circumference is going to be, if I simplify this, will be 5 pi over 12. Okay, well, I'm sorry, not the circumference. One of these little pieces here is 5 pi over 12. But then if I want to find what is the length here, x, notice that it's 12 pieces going this way. I could find that x is just equal to, I would have 5 pi over 12 times 12. Okay, so this piece here, once again, like one of these, that's what we just found. We took the circumference and we divided by 24. So one of those distances is 5 pi over 12. Okay, but when we line it up like this, we're just multiplying by 12. So let's see. If we do that, we're just going to get 5 pi. Okay, which is going to bring us close to 16. All right, so close to 16. So 23 is going to be choice 2. All right, once again, I think it's a little sloppy because it's like they're allowing you to use this arc, but that's why they say to the nearest integer. Like, so they're kind of using like an approximation. Oh, thank you for more tips too. I really appreciate at Kevin K for the tips. And those emojis are so cool that come with the tips too. It's, yeah, nice to see. So thank you. Thank you so much. I really do appreciate all the support. All right. Which statement is sufficient evidence that triangle DEF is congruent to this one? All right. This is not enough because this is just like side. Okay. Like if like AB is equal to DE and BC is equal in measure to EF, SS is not a postulate. So no. All equal angles would be enough to show that the triangles are similar. Okay, so this is enough to show that the triangles are similar, but not congruent. Because if I have, like, let's say this triangle here, and I expand it, like it's similar to the one I started with down here, but it's clearly a different triangle. So, all right, let's see here. There's a sequence of rigid motions that maps AB. So let me just color code this. So AB maps onto... Oh, all right. So rigid motions is looking okay. Let me just see if that one, maybe this one's it. So AB is mapping onto DE. And then they tell us, so AB is going to DE. BC is mapping to EF. And then finally, they're telling us that AC is mapping onto DF. So this one here is looking like it. That's basically like SSS congruence. Okay, it's mapping onto means it's landing on it. There's a sequence of rigid motions that maps. All right, the problem with choice 4, so 4 is almost good, is right here. This piece is no good. All right, AB mapping onto DE. See, it's still like green and green. And then angle B mapping onto angle E. The problem is they said point A onto point D. They didn't say angle A onto angle D. Then it would be good. Then it would be the angle side angle postulate. But they only said point A to point D, not angle A to angle D. So that's why 4 is out. Definitely choice 3. Okay. So that is the multiple choice. I don't have a compass set up right now. So let me think about this. What am I going to do? All right. So we don't have a compass. I could open the program. So maybe I'll do that. Yeah, I'll just open up Smart Notebook. And I'll just copy and paste this and show how to do it. Let me just see if I missed anybody in the chat. But no, I'm happy to be able to help you all. And thank you everybody for commenting, you know, who were here and stopped by. I might, let me see where we are at. I've been streaming now for almost 2 hours. I mean, I kind of went on a bunch of tangents, like talking. So obviously you're not going to talk during your actual regents, but 3 hours is like plenty of time, I think, to do this test. Hey, I watched all of your, an 89 on the, very nice. Very nice. I'm happy to help, Dave Braun. Yeah, see, that's why, thank you for stopping by, because like I do my best to get back to all the comments and stuff, but it definitely got, you know, a little bit more challenging, especially around the time of the live streams. Like there was just, I had, that was like that was honestly my busiest day on YouTube, was the day before the Geometry Regents last year. I had like 52,000 views or something crazy and a ton of comments. And I usually I do my best to respond to like all the comments, unless they're like really mean comments. Then I'll just say like, all right, like, you know, like it's one thing if someone's giving me constructive feedback, and when someone's just like, you know, just not being kind, I'm just like, all right, well, I guess, you know, you don't really want to have a conversation here. But I really do my best to get back to everybody, and it got really difficult too. So someone like you, Dave Braun, I'm just happy that you found the videos helpful. But awesome job putting in all that work. Because anyone who stops by, like you're doing what like a lot of people are not doing. Like you're putting in like this extra time when most people, like, it's like so much easier to not put in extra time. So awesome stuff. But I'm glad I could be, you know, like of some help in this situation. So here, construct a, let me just make sure this is actually showing up nice. Okay, so we could see this. I just copy and pasted it so I have a compass tool. So we have to construct an inscribed square and encircle T. So I just draw a line segment going from any point through the center to the opposite end. And now I'm going to construct a perpendicular bisector. Okay, so I'm going like this. 1, 2. And now I move it over to this point. And you don't have to be an artist at the Regents, but if you freehand draw this and you're like a bad artist, they're definitely taking off points. Okay, so here is what we're doing. We're constructing a perpendicular bisector of the diameter, because the concept here is, if you think about it, we're using the properties of a square. In a square, it has all the properties of a parallelogram. It has basically all the properties of a rectangle and a rhombus. So by doing this, we're building the diagonals of the square. Okay, so if you look at the points that I just drew in here, I have these 4 points, but I know that now this line segment here and this line segment here are perpendicular. So if I have a bunch of right angles here, then what I have is I have my diagonals are perpendicular. My diagonals are going to be congruent, because notice that it's a straight line segment going through the center of the circle, and all diameters are congruent in a circle. So my diameters are congruent, my diameters are perpendicular, and you could see here that these are all radii, so like these segments are all the same, like this. So my diagonals bisect each other. So it's like, it's got everything that we need to say that this is a square. But of course, I can't just say it's a square and celebrate. I actually have to draw and connect. So 1, 2, 3, and 4. All right, and there's our square. There's more ways to do it, but I don't know. This way is my favorite way to do it. So that's the one. Yeah, I'm going to stick to. Oh, yeah, and have a great night at Dave Run. Is it possible to construct the piece without using the compass? I mean, if you're a great artist and like you do some cool stuff with your hand and you could keep it, then yeah, like if you're really good at drawing freehand, I'm not that great of an artist though. So I would definitely need a compass. But I mean, for it to be accepted as credit, you need to use a compass. Like that's really what they're looking for. All right, so that's 25. 26. So now we have to explain why angle NLO. So this was like a pretty old Regents, and explaining why it's kind of annoying, because like you just want to do the math and get what the measure of angle NLO is. But now we have to like really script out everything we're doing. So we have a parallelogram, and so this quadrilateral is a parallelogram, and our target is angle NLO. So we're targeting this one here. So here there's a few ways that we could do this, but the opposite angle concept is jumping out at me. Like right away, I would say the measure of angle O is equal to 118 degrees. Let me just, yeah, I don't know why I wrote 1/8, but whatever. So 118 degrees. And I have to explain why. So if I just say this and I don't put a reason behind it, they're going to tag us here. So the measure of this equals this, because opposite angles of a parallelogram. So parallelogram, okay, are congruent. All right, so that's more than enough. I mean, I can't imagine they're looking for something too crazy here. And now notice we have a triangle here. So I could just subtract the sum of these two angles from 180 to get the measure of angle NLO. So the math that I'm just, like if I could just do any math that I wanted, say, okay, 118 plus 22 is going to give me 140. And then this minus this is 140. I'm sorry, 180 minus 140 is 40. So the measure of angle NLO is 40 degrees. But remember, I have to explain why for 2 points. So I'm guessing this step counts as 1 point with the explanation, and then the next step counts as 1 point with the explanation. So here, I would say the measure, I don't know what's going on with this pen, of angle NLO is equal to, we're going to have 180 minus the sum of those two angles. So we have 118 degrees plus 22 degrees equals 40 degrees. Okay? Because, so explain why. The sum of the three interior angles of any triangle, of any 2D triangle, is 180. So the sum of the three interior, I'll just abbreviate, interior angles of a triangle is 180 degrees. All right, I'm happy with this. For 2 points, like, don't write a short story. Like, this is kind of pushing it, but I don't know. I feel happy writing this much. And I guess we can move on. Cool. So question 27. Oh, this famous kind of question. The set of the axis below is optional. All right, so if you love formulas, so the formula you want to know for this ratio question, m to n, where you have like a point A and a point B, and they tell you like basically the ratio of this to this is m to n. Like, what are the coordinates of P formula? So the formula is you have like the x1 plus, and then you have m over m plus n times the difference of the x's. Okay, and the y formula is basically the same, but just y1 instead. Okay, I personally don't like formulas, but like Fortnite, what you were saying before, like, oh, how do you remember all this? I understand it. Okay, I understand why this formula works. So x equals x1, y1 is the one like more to the left. So I'm going to have negative 6 plus my m value here is 2. My n value is 3. So I have 2 over 2 plus 3 is 5. So 2/5 of, and now x2 minus x1. So that's going to be equal to 10 on the inside. So x is equal to negative 6 plus, and then I have 2/5 of 10. And then 10 over 5 is 2. 2 times 2 is 4. So I have x equals negative 6 plus 4 is negative 2. And then my y value is going to be equal to y1 is negative 5 plus the same fraction 2/5. And now I have the difference of my y values. 0 minus negative 5 is 5. And 2/5 of 5 is 2. So this is negative 5 plus 2, which is negative 3. So state the coordinates of P. I would write it as a point. Is going to be negative 2, negative 3. Okay, that's just using a formula. And if you're just happy to use a formula, then just use the formula. Otherwise, I like the second way more. Visual, negative 6, negative 5. So you plot this. Negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So here's A. And then point B was at 4, 0. 1, 2, 3, 4. All right, because this way that I'm about to show is more conceptual. So they're telling us the line is being broken in such a way that, let me move this point. Breaking it into a ratio of 2 to 3. So like the concept is 2 equal parts this way and then 3 equal parts this way. So you see it's like 2 like to 1, 2, 3. Like there's that ratio. Okay, so like that's what I'm looking for in my head. And now if I want to get to from here to here, remember this was, let me just look again, negative 6, negative 5. So this is negative 5. This is negative 6. And this is over here at x equals 4. So if I want to get from here to here, it's the rise over run method again. So the rise over run concept shows up a lot. So I go up 5 units, 1, 2, 3, 4, 5. And I go over 10. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I could just do 4 minus negative 6 is 10. But if I'm breaking this line segment into a 2 to 3 ratio, that's 5 equal parts. See, 1, 2, 3, 4, 5. So what I'm going to do is I'm going to divide each of these by 5. And you'll see where this is going in a moment. Okay, so divide each of them by 5. So this is the, remember, this is for the concept, like the conceptual way to do this. All right, which is more like, it's going to stick more. So I go, instead of going up 5 over 10, I'm going to go up 5 divided by 5. I'm going to go up 1 over 2. So watch what happens. Up 1 over 2. Up 1 over 1, 2. Up 1 over 1, 2. And it's going to take me 1, 2, 3, 4, 5 jumps. But remember, we want to break this into a ratio. Point P has to be located in such a way that it breaks this ratio. Oh, I'm sorry, it breaks AB up into a ratio of 2 to 3. So you see there's the 2 and there's the 3 after. And where is it located? It's located at -2, -3. Okay? So I really, really like this because it's like true geometry. Okay? What's happening there? So cool. All right, 28. So more, these are the 2-point questions. So the 2-point questions are like, I'm not going to call them easy, but there's like not a ton of like steps to them. All right, they really shouldn't make it like a 5-step question for 2 points. That would be insane. So we have a ramp. It's 4.5 feet up. Find, determine and state to the nearest degree the angle of elevation, that's here, formed by the ramp and the ground. Okay, so if we want to know that angle, I'm thinking this side is opposite, and across here is the hypotenuse. See, we have a right triangle here. So remember SOHCAHTOA. This side and this side is making me say opposite hypotenuse, so I'm thinking sine. So here, we don't have to show a ton of work, but just know that sine of the angle theta is equal to the ratio of the side opposite over the hypotenuse. Okay, now one thing to point out is the difference between these two. If I have something like y equals sine x, when I use the inverse trig functions, so in this case here, sine, cosine, or tangent, I have an angle, I feed sine, cosine, tangent an angle, and they give me a ratio. But if I have something different, if I have y equals sine inverse of x, which is another function on the calculator, this is the opposite of sine. Instead of doing angle ratio, I would do ratio going into the inverse function, and it would send out an angle. All right, now what I mean by this, if I pull up the calculator, is I'll take one like sine of 30 degrees is equal to 1/2. So if I do sine inverse is second sine, and I plug the 1/2 back in, it's going to send me back to 30 degrees. Okay, so that's how those functions work. So then here, what I'm going to do is if I want to know what theta is, so I want to know what's the measure of the angle theta. So the angle theta, and I'll just call this the angle of elevation. So I'm truly answering this question. No funny business. So my angle of elevation, I'm going to do sine inverse of the ratio 4.5 over 11.75. So this is just all calculator work. So I'm going to just go ahead and do that. So sine inverse, and just we know what we're typing in, 4.5 over 11.75. And to the nearest degree is 23 degrees. Okay, so I'll just copy and paste this here. See that after the, after the whole number here, let me just get out of that mode. It's just not letting me write. Okay, here we go. Now we're back. See, it's a 5, so we round up to 23 degrees. Okay, so I'll just say clearly 23 degrees. That is our answer. All right, 2 points. Yeah, that if you want to prove a quadrilateral is a parallelogram because the diagonals bisect each other, that's fine. Usually how you do that, Fortnite, is you show that the diagonals have the same midpoint. If you're on the coordinate plane, if you could show the diagonals have the same midpoint, then that means they bisect each other. Like you'd have to write a few sentences, but, or like you'd have to explain it in word, like, cleanly in words, but that would be the idea. Okay. In the diagram below of circle O, we have the area of shaded sector. So the area of the shaded sector is 12 pi square inches, and the length of OA, the radius, is 6 inches. Determine and state the measure of the angle. Oh, okay, so here we're going to think proportionally here. So the area of a circle is pi r squared. So the area of our circle, the full area, is pi times, and the units on the free response, they're not checking on you. All right, but I'll just write them here because I just, feel weird not. The radius is 6 inches. So the area would be 6 times 6 is 36 times pi and then square inches. Okay, so we have 36 pi square inches. And they're telling us the area of the shaded part is 12 pi square inches. So let's think about, like, what is the ratio of this area to the total area? So if I do 12 pi over, so I'm just looking for the ratio here. So 12 pi over 36 pi. See how this simplifies to 12 over 36 simplifies to 1/3, which means that this sector here, AOC, is 1/3 of the whole circle. So if I want to know the measure of the angle, the central angle here, I could just do 360 degrees times 1/3. That would be 120 degrees. Okay, so the measure of angle AOC is 120 degrees. All right, so yeah, because it's 1/3 of the circle here. So we're taking 1/3 of 360. Nice question. Nice little, yeah, ratios and proportions are really, really, really big. Like, shows up a lot of math. All right, 30. Yikes, a lot to write. This I might just say, let me see how many questions I have left. I got 31. 2 is a lot. Yeah, I might call it a day after this one, and then I will do the rest. Yeah, I'll do the rest of these tomorrow then. Okay, like, yeah, after my kids go to sleep, that's when I do these live streams. I have to wait for my kids to fall asleep. So that's when I will, yeah, that's when I'll do these, the ones after this. Actually, you know what? I'll just like address the chat now. Maybe I'll just cut it here because this one it also requires a lot of writing. I think 2 hours on is like, somewhat like okay to process. But yeah, because what do we have? Yeah, 4 people right now. I also think people have school tomorrow, and it's not a Regents tomorrow, so people might want to actually get some sleep, myself included. I should probably go to sleep earlier. So yeah, at this point, I guess I'll just say thank you all, the people who stopped by for the actual live stream, and anyone who's watching it now, the replay. Thank you for stopping by and or for watching. I'm just happy to be able to help, all of you, even people who didn't need the help, who just want to stop by and say hello. Like, I'm glad you stopped by, and you're always welcome to stop by at any point in the future to say hello. I really do look forward to seeing, current and former students. So it's nice to, reconnect and stuff. So thank you for supporting, and good luck on your Regents or whatever math test you're taking if you're using this to test prep. So take care.